We have very excited about our guest, Sean Cornell from Shippensburg. He is an associate professor of geoscience at Shippensburg University. Did his grad work University of Cincinnati and his undergrad work at University of Rochester. Teaches across the spectrum of geology and oceanography. But his research is focused on assessing coastal processes, environmental change of the mid-Atlantic. He's interested in clastic carbonate sedimentology and stratigraphy in response to carbonate systems within foreland basins. Those interested in responses to climate change. Sorry, I stumbled over that. And he's currently using sedimentological methods and shallow geophysical methods, including GPR, to evaluate stream morphology, cave occurrences within Great Valley, Susquehanna River Basin region. All right, so let's welcome Sean Cornell. Speaker notes. There you go. You get to just advance on the keyboard.
Great, thank you very much. So thank you, Amy. Thank you, Al. Amy participated in a version of this talk that I gave for Fort Hunter Park back in the spring and said, hey, would you like to give that talk again? So this is basically that talk, but tweaked a little bit more with some new exciting findings, in part due to one of the new collaborations that the PASHE state universities have going on, and that is our summer geology field program. And what's really exciting about that is, number one, the universities could not offer a summer field geology program by ourselves. And so now we have a summer combined field camp that travels here in Pennsylvania. So we're excited to get that offered for the third summer coming up. But the new twist on this talk actually resulted from some of the field work that we did this past summer with that field course. So tying in some of the karst features. And again, it was this talk overall is really sort of derived from the interests of my students over the last 18 or so years at Shippensburg, asking really interesting and intriguing questions. And so, I teach a lot of different courses, and it's really exciting when a student sort of steps forward and says, "Hey, I'm really interested in my backyard." And so my introduction to Pennsylvania's Riverbanks sort of were inspired by my students. And so I will sort of begin to say that this is a work in progress. This is not complete science, but it's also me going back into the literature and really kind of going back to some of those icons of Pennsylvania's geologic history, and in particular a number of scientists, including some from here at the survey. So I'll get started. But again, as I said, this was folks from the Fort Hunter who were really interested in, what was this bluff all about? So I put this together in part for that. So I'm gonna, number one, if you kind of go to their website, Fort Hunter Park, it kind of begins off in their website, sort of begins with this sort of built on a bluff, ... And so what I want to do is sort of think a little bit about this sort of overall overview geologic setting, thinking about these bluffs and what we might refer to as river stairs. I've heard these terminology used quite frequently by folks who live on the river, and the idea of nature's highways. And so, why does nature travel these highways, and why do we place our highways on them? And we'll talk a little bit about river terraces, and then kind of get into the record, if you will, of these terraces and climate change, and then the new addition, which is thinking about our cave systems locally. So so where is Fort Hunter? Where are we? Obviously, Middletown is located down there. And I don't know if folks online will be able to see my cursor moving or not, but there's Middletown and Fort Hunter and Dauphin, which I'll talk just about in just a minute. And right here is Fort Hunter Mansion, And this is, as you can sort of see in the background, the river behind it. This sort of flat area is intriguing. The mansion itself is much younger than the original fort. The fort was built in the middle of the 1700s, abandoned and left to disrepair, and its site is still unknown. Actually, we have a number of folks, both with the State Historic Preservation Office and some of the statewide archaeological groups, including my own colleagues at Shippensburg, are still working to find the footprint of the original fort. But anyway, it was situated here on the bluff. And if you go just to the next meander to the north upriver, this is a photo looking down from Second Mountain, looking at Dauphin. And one of the things that I think you can see, number one, is you see the meander, the cut bank side of the Susquehanna River at current river level. But then you see the highways and the different levels as you step back from the river. These are sort of these stepped down features, right? And so the question is, where do these come from? How do they arrive here? And a little bit about when. And the photo down here in the lower left is actually at Fort Hunter, and you're looking across to Marysville there. And what I didn't show here are the fact that on the Marysville side, there are equivalent stairs, if you will, as you sort of work your way back away from the river. So those stairs, yeah, I highlighted them there to sort of be able to point them out. But it's hard to see sometimes with the vegetation. Beautiful, aerial photo here, just to give you, again, a little bit of geologic and geographic sense of place. So you can easily see the two yellow arrows pointing out to the village of Dauphin, or the municipality of Dauphin, as well as Fort Hunter. And they're sort of situated here in what was the sort of cut bank side of the Susquehanna River, where it cuts through Second Mountain and North Mountain. And this is just a wonderful tool. Sometimes within Google Earth, you can sort of tweak the vantage point like you would be from an airplane. And it does give you some interesting perspectives. And so it's worth, if you've never played with Google Earth Pro before, you can get some of these interesting perspective views. But right in the foreground there is Fort Hunter. And again, the 322 as you go north, right? So one of the other favorite tools that I have, and it's a shout out to Al, something that I use almost every single day, and of course I'm pushing students to use quite frequently, are a number of tools. This one in particular is actually CalTopo, but I'll show you another resource that is from PAGEO, right? The Pennsylvania Geological Survey's online. To me, it's this beautiful, beautiful tool. But anyway, here is a physiographic map using LiDAR, and again, same geographic features identified there. Geologically, what we are looking at along that blue dotted line is a topographic profile. Now that one is taken from PAGEO, and what I did is I just went ahead and placed schematic representation of what the strata are doing in that location. So you have this sort of Cove Mountain syncline feature, and it actually is a plunging syncline feature. And so this image out of my geology textbook that I use. But anyway, so the area between Fort Hunter and Dauphin is going into the limb, the southern northward dipping limb of this Cove Mountain syncline. So geologically, one of the beautiful tools that we have because of our LiDAR is being able to get in and actually really start tracing out bedrock units, even in a higher resolution way than we've ever had the ability to before. And so what's really pretty cool here is that you can look at the Silurian units, of course, the Ordovician units down here in the Great Valley, below the south of the Tuscarora sandstone. But as you get up of course, you cross over the Siluro-Devonian units and almost all the way up to the Mississippi in there, where you get close to the Specti Clough. So again, the bedrock ribs sort of show up, but what's really important here is to see where the bedrock is interrupted by the cover, and the cover meaning the soil and the rock, talus, the materials that are derived from those bedrock units, but are put in motion due to time and weathering and colluvial processes as well as fluvial processes. And so, yeah, I just point out there in white some really interesting and remarkable landforms that we now know are pretty substantially tied to the periglacial environment that this region experienced just 24,000 years ago, and the development of some of the solifluction features that developed off the southern slope of North Mountain there. But anyway, and you can also see them on the north slope of North Mountain. And now that we begin to see them and we know what that pattern is from, we can begin to pick those features out. And those, of course, are really remarkable, in these maps. But the part that I want to spend a little bit more time on is what's really sitting on top of the bedrock ribs, especially around the sides of the Susquehanna River. And so one of the other tools that I like to use, again, I call them GIS for dummies, and that is a tool called GeoMap App. GeoMap App is a online system that is primarily used to serve oceanographic data, believe it or not, but it has built in it something called the GMRT, or the Global Multi-Resolution Topography Viewer. And it's sort of like LiDAR data. It's a little bit coarser scale. But one of the nice things about that tool is that you can recolor the LiDAR in a sense. And so you can, in that lower left image, you can see a recolored version. And what I did is I chose to use a color scheme where I could identify the fluvial-based sediments, right, the riverine or near river deposits, and separated those out from, the bedrock features for the most part. And so what you find in that is that there are a number of deposits, including these gravel pits, that are no longer recognizable, really, even in the landscape because of the human overprint of the physical landscape. But I'm going to zoom in and talk a little bit more about those fluvial components. And so again, this is a beautiful, again, derived from GeoMap App. Again, I recolored it a little bit instead of using a blue, but again, you can really see some interesting components of the fluvial system. So the white line here, the light blue color, is our modern river channel. And then in the blue is the historic course. And what you can see clearly here is that the modern river is what we would refer to as an underfit or even a misfit fluvial system. That is, that the modern flow that's in the Susquehanna River cannot explain the shape and morphology of the broader valley of the Susquehanna River. And that suggests hydrodynamic changes in the Susquehanna River's past and, of course, into its future. There are a few other observations that you can make here, including, that the river is going to narrow, and of course the river is going to become, constricted, and the fluvial flow will increase. And then, of course, in the softer bedrock units in the valley floor, right, the water is the river will widen, the flow will slow, and we'll see some deposits, especially with some of the longitudinal bars and things like that would become islands within the stream. And so I will point out here that most of the time the shales and the limestone units are the things that permit the widening and meandering of the river system, whereas the sandstones and conglomerate units are obviously the ridge formers and constrict the flow accordingly. So this is a little further north, and this is a place known as Asylum Township, but I just fell in love with this image. This is just outside of sort of northwest of Scranton. So still upriver from here. And I think you can easily see that there are a number of stair steps, if you will, within the sort of point bar area of just on the right-hand side of this image. And so you go back to Louis Peltier back in 1949, and he started asking questions about these features. Even before him, George Stows and others. But what I find was really interesting here is a statement from that publication, and you can read that here. But the Susquehanna is and its branches are bordered by deposits of sand and gravel, which form terraces above the riverbed. The terraces are remnants of once continuous gravel and sand plains laid down by the rivers on a continuous grade, now represented by the height of the existing remnants. The sands and gravels of the terraces are coarser than the sands and silts now carried by the rivers. These successive stages of alluviation were, therefore, not laid down by floods similar to those of the present, but are to be correlated with the glacial climatic regimes of the Pleistocene. And so this has been, these deposits have been known for quite some time. And so again, these little sort of stair steps can be readily observed, and most people, especially with these beautiful farmlands, where they have removed the canopy to make it a little easier to see. So again, coming back and thinking about PA Geode as a wonderful resource, one of the tools that went away at one point, and then I quickly, emailed and called, and I think it was Craig Ebersole that I talked to. I said, that's got to come back, right? That topographic profiling tool, because I use it a lot with my classes. Students today, modern students, have a rougher perhaps, reading topographic maps. So giving them the ability to look at elevation change is an important task, and asking them to do a manual topographic profile. They do. We teach them that technique, but that takes a lot of time. If you just want to ask a general question. So anyway, the PA Geode has this beautiful topographic profile tool built into it, and it is pretty darn remarkable. The scale and resolution of the profiling tool is great. So I love it. And so you'll see these used quite frequently. And these are, I just put these topographic profiles together because these are parallel profiles. The upper one is literally right on the river, so you wouldn't expect to see much in the way of a profile because it's this surface of the river. But if you move just in a little bit, and you kind of cross through the area where Hunter Park is actually located at, one of the things that you're going to find as you step down over Fishing Creek is that there are a number of stair steps that are preserved just up from the Susquehanna River that are not actually recorded right at the bluff itself where Fort Hunter Park is built. And so when you do that analysis, you can start to see quite specifically these different stair steps and sort of stairs at 95 to 96, 97 to 98, 99, 100, 101, 102, and so on and so forth. And so I have them highlighted, or at least in partially highlighted there. And so now what if we take those profiles, instead of run them, parallel to the stream, let's go ahead and look at transverse or river perpendicular profiles. And when we run those again, one of the things that comes out are these, repeat elevational steps, right? And so if you look at these, the river level is sitting at about 93.7 meters above sea level, and then we see these additional steps. And so, when we started looking at these and asking questions, of course, what are these all about? Well, right, that's when you go to your geomorphology, textbook. You go back into your understanding of, fluvial and alluviation, processes, and we know that rivers erode. We know that rivers transport and deposit sediments. And so when we think about especially long-lived rivers systems like the Susquehanna River, right, they're going to produce many flood events over their geologic lifetime. And, as we all know, during a flood, right, the river floods over its banks. It will leave behind some sediments on the plain. the water itself will retreat back to the channel, and the sediments will build up and stack up over time. And so, not surprisingly, when we have large floods, right, these are obviously big news-making events. But what we don't often think about is the fact that as the rivers continue to erode downward, those rivers will re-incise, they'll remobilize sediments and move them and flush them downstream. So a lot of times rivers not only will put down sediments, but then they'll remove those sediments. Those records will be lost, pretty rapidly, especially as the rivers are, at what we call still stand. That is, they tend to migrate laterally and remove prior sediments. It's when they're, when the phase of the river is being adjusted by tectonic or, sea level events, that we tend to be able to strand some of these deposits and leave them behind. And that's why these sort of tributaries that enter into the Susquehanna become really important, because their records can sometimes be preserved. Again, once the old floodplain is abandoned, sometimes, right, we'll get these terraces that result. And you can sort of see here, in this cartoon, 4 different terraces: an upper terrace 1, 2, 3, and then of course a much lower terrace level that is the modern floodplain. And again, these terraces will be, in many cases, or can be abandoned. And when we talk about the surface, the flat part of the terrace, we call that the tread, if you will. And then the bank, the steeply dipping part, we might refer to those as risers. And again, as I said, the river cutting, whether or not you're going to, mobilize and remobilize sediments or strand them and leave them behind, is a function of base level, right? So we'll come back to that idea in a few minutes. But here's a beautiful photo. This is in the this is in the Alps. No, I'm sorry, the Himalayas. This is the footlands of the Himalayas. And again, one of the beautiful things here is that you can sort of see a number of terraces, preserved. And in this case, they are strongly tied to uplift of the Himalayas, right? And so, one of the big reasons why we can get river terrace formation is through isostatic uplift or tectonic uplift in a region. So our region, this region of Pennsylvania itself, was not necessarily covered by ice, but just to our north we were. We were within the realm of the depressed territory here, with the weight of the glaciers. And so the landscape had been subsided. And then once the glaciers have melted back, the region can rise, right? This rebound effect. And so when that happens, the rivers can entrench downward. But of course, there's also, so you have this tectonic uplift effect. You also have the climatic or the subsidence effect, but you also have obviously the effect of climate change, and pretty dramatically so within the last 2 million years of our history, where we've had the pretty substantial waxing and waning of the Laurentide ice sheets and the sea level rise that would come each time from melting, and then the sea level fall from advancing. And anyway, these river systems, river terraces, are a hotbed, if you will, for studying relationships between tectonics and climate and erosion, and the many different ways that these interact and interplay with each other. So again, I'm not going to spend a lot of time. This is just another beautiful. I just can't get over some of these. This one happens to be in Tian Shan in the Foreland Basin. This is on the northern side of the Himalayas. And again, you can see this beautifully incised gorge. But what drew my attention, of course, are these sort of step terraces in the background. And so again, these phenomenon are and features are pretty cool to spend some time getting to understand. So and again, this is research in progress. And so in the case of Tian Shan, we're pretty well able to link the incision, the cutting downward, directly to the uplift of the Tibetan Plateau and tectonic activity in the region, as well as some climate change, as it turns out. Right. But we think about our own region, and we think about the broader Susquehanna River basin. And here is an image from Stanford et al. That takes you back 22,000 years ago to LGM, right? Our last glacial maximum. And at that point, there was no Chesapeake Bay. The Susquehanna River actually flowed all the way down around sort of the hook of the Delmarva Peninsula and out to the Norfolk Canyon. And emptied, the sediments that it entrained from Harrisburg and Fort Hunter and other places, and emptied out into the upper part of the continental slope and rise environment. Of course, in the 22,000 years since then, sea level has risen quite dramatically, flooded and drowned the Susquehanna River, and causing sediments to be backed up, if you will, in the upper part of the Chesapeake Bay, and also within the river. But the river then doesn't have its ability to cut downward like it did 24,000 years ago. And so, I showed you a couple of pictures from the Fort Hunter, Dauphin area. But going back to some of the early workers, some of the important sites that were published on include Muncie further north, up closer to Williamsport and the areas to the north, and then Marietta just down to our south, and not too far away from where we are here. And my student, Emery Saylor, is from McVeigh near Mattawanna, and he was like, "Let's go check these things out." He said, "I've been playing on these my entire life, and I want to know more about them." And so we're going to kind of take a look at that here in just a second. But again, and we can find many, many more examples. Whether you look at the main stem, or you look at the West Branch or the East Branch or the Juniata River, which is where the McVeigh town is located at, we can find these features now with the help of LiDAR. These are things that have been hidden for so long. And now we can start to do some really dramatic and integrative studies now. So before I go too much further, the other thing that I wanted to point out is some work done by Engel and others, because one of the things that they did was they looked at these terraces, these sort of fluvial systems, but then started looking at them from the soils development that occurred on top of them. And they actually identified 7 terrace levels that had beautiful soil development. And that's really critical here, because soils will only develop on a terrace if that river level gave it time to do so. The river has to stay stationary for a period of time, so that the base level is not cutting, so that the groundwater, the infiltration processes can basically become set and stationary for a period of time. And so, they were able to look at, the complexity of the soil horizons, the thickness of, the subsoil zones, the B horizons, different colors, of course, the accumulation of iron and aluminum and manganese, and these things that, again, they take time to accumulate, right? And so they did some work, some beautiful work that was, again, published in '96 and in several of the Field Conference of Pennsylvania Geology work. And of course, Scott Engel, when I was at University of Cincinnati, he was at Dames and Moore. So I spent a little bit of time interacting with him many, many, many years ago. But anyway, I took out a bunch of slides, but I wanted to show this one. This one is for Marietta. Again, I've taken the bedrock geologic map there, but then superimposed the geologic coloring on the LiDAR. So you get these beautiful, stacked images. And so you can sort of see the bedrock here is sitting below these things, but this beautiful series of stairs, these steps. And the beautiful thing about Engel et al. Is that they went ahead and they numbered these things. And they, of course, indicated the flood of record, which, of course, the flood of record in our region was Agnes in '72. Agnes flooded 3 lower terraces, but could not come up and obviously go up to the level of 3, 2, and 1, and neither the uppermost, they call QTG. And so, if you look at these, terraces, again, from an aerial photo here, it's hard for you to see them with the human landscape draped on top of the physical landscape, but they're there, and the elevation profile shows where those are. And I went ahead and took the modern LiDAR and added their from the best that I could using their publication to line those up. So you can sort of see where each of those terraces would occur. Now, when we go up to McVeigh and up to Juniata River terraces, again, LiDAR is used, and one of the beautiful things that you can do is, you can pick out effectively every single one of those terraces from T6 all the way up to TG, right? And so Emery, for his 1 semester research project, and by the way, Emery now works at the USGS, and he's been doing a lot of work on the Juniata River and some of fluvial modeling there, along with other tasks. But this was his backyard, and so he convinced me to come out, and it wasn't too hard to convince me because I had previously taught at Juniata College, and so this was one of the places that I took my intro geology class to talk a little bit about some of these features way back when. And by the way, this is at a bank full stage. This was Hurricane Felix. This was 2 hurricanes that came through back to back. They're about 2.5 weeks apart. And Huntingdon, where I lived, was actually we couldn't get in nor out of Huntingdon during that flood. And so this was taken once we finally were able to drive out of Huntingdon and cross over. So I went down to see these images, or take these images. So when you get out there, thankfully Emery had good connections with the local farmers, allowed us to get out there and do some sampling on these terraces. And one of the questions that Emery wanted to know was, clast size. What does that tell us in class shape? And we really were kind of curious to see if there was differences between lower and upper. And the textures were pretty remarkable. And so I just took one diagram out of his paper, and I'm not going to do it due diligence in explaining it in this time because it's quite complicated. But what is really interesting is that the modern sample, the modern system, site number 1, is incredibly well-rounded sediments. These are sediments that have been very long transport distances, but they're also they tend to be extremely well sorted. The variation in grain size is much lower than we might expect. But as we make our way to higher and higher terraces, one of the things that we start to see is more and more of the sort of angular textures coming in, indicating substantially less transport history. And of course, the grain size of those were actually substantially larger, indicating different fluvial conditions. And so there's a lot more data to think a little bit about on this. And Emery did a beautiful statistical assessment of that, but ran out of time to finish before he got his job. So we have to finish this paper, Emery, if you're paying attention. But anyway, we will. So these clasts are, and he also identified them, by the way, to rock formation as best we could. So identifying whether they were, sandstones, if we could tell which was a Tuscarora or whether it was, more of an Arcosic, or a Greywacke sand, or and then of course some of them were chert and some were limestone. And so trying to track to see where they were coming from. In this particular study, he found one clast that was igneous, and it was not a diabase, which is our primary igneous rock of Pennsylvania. And so if you go back to some of the earlier literature, they indicate, occasional clasts of gneiss and things that were brought with the glaciers from the Canadian Shield. But to find something like that in the Juniata drainage is very peculiar, because the Juniata drainage is supposedly not glaciated. And so, yeah, we'll leave that for now. But that brings me to obviously thinking about terraces and climate change. And so one of the things that's pretty dramatic, and the last few summers, during the summertime, the water levels have been particularly dramatically low, and you can get out there and see some of these extremely large boulders sitting on the bed, right, of the Susquehanna. And you have to ask yourself, how did they get there? Because it's certainly the modern fluvial conditions are not adequate enough to move them. They've been sitting there. This same boulder is basically here today. It has not moved. This one happens to be near Marietta, but even all the way back in the 1930s, they were talking about these as being brought into the Susquehanna Basin by glaciers, right? And so although there were some that were from within the basin, right, we see large boulders and other rock materials that were brought into the basin, and some they thought by floating ice and brought down into the river system. So we'll talk more about that, and some of you probably we don't have time to talk about Lake Leslie at all, but another large dammed up ice margin lake that broke through and sent a lot of water down through the Susquehanna River. But oh yeah, I forgot I put this in there just to give you sort of perspective of the parts of Pennsylvania that were covered in ice, in our glacial history. So again, if you go back to George Stowe's, this is 1927. He published a GSA bulletin called "High Gravels of the Susquehanna River above Columbia, Pennsylvania," and he did some really interesting. There's some really interesting components there. Rounded pebbles of sandstone of more distant origins, some things of Cambrian quartzites of local. Some of them are really interesting because they have beautiful scalithos still in them, and so that they're Cambrian sands, but others are clearly younger units. And again, the variety of rock units within the terraces changed. And so the uppermost high river, right, the second gravel terraces and the low river gravels, they have different compositions. And of course, this lowest terrace is the one that Harrisburg is built upon. Of course, it also carries pebbles of granite, other rocks foreign to the river basin, and large masses of quartzite and diabase. And so it's where the rivers are. It's where most of our roads are built, and so on and so forth. But what I've done here is, again, I've gone ahead and placed the topographic cross sections of Muncie, McVeigh, Marietta, and even Fort Hunter. And when you do this, unsurprisingly, you begin to see every single terrace is basically present. Their elevations change a little bit as you work your way downstream, but they're all there. Okay. And so if you go back to Stowe's 1928, of course, he talks a little bit about peneplains. And so I want to kind of drop that piece just a little tiny bit there. What you'll see here is a sort of a cross section going from Sealands Grove on the left down to Harrisburg and Point South on the right of this image. And Stowe's identified several large, sort of slightly dipping elevations that refer to these things called peneplains, right? So I'll show you a couple of graphics in just a minute to help you understand what these things are. But essentially, when base level is established for a period of time, the river can't continue to cut downward, so the river migrates back and forth, eroding laterally, and so that can level out a terrain quite dramatically, right? It's only when the base level of the river system is adjusted downward that the river can then begin to cut down and leave behind a record of that higher elevation, right? And so the Kittatinny peneplain, the Wiverton, right, the Dauphin, the Bryn Mawr, the Brandywine, the Sunderland, all of these other peneplains are indicated in here. And of course, the solid line at the bottom is the current profile of the Susquehanna River, at least in 1928. And so even Stowe's had the idea that the upper terrace, right, the so-called Sunderland, or the upper gravel covered, was he thought to be Illinoisan, all right, in age. So Illinoisan, meaning we just went through last glacial maximum, Wisconsin. And so the Illinoisan was the prior episode. So we're talking 120 million or 1,000 years ago, something like that, where it sort of ended. And then we went into what we call the interglacial, the Sangamon interglacial, and then into the Wisconsin cooling. So anyway, the middle terrace, he indicated, right, was probably early or middle Wisconsin, right? And he believed that the lowest most was late Wisconsin, so within the last, say, 10 or 12,000 years, right? And so what I did is I just went ahead and tried to, again, reconstruct, if you will, the peneplain horizons, and I just identified based on pattern. I didn't have time or energy to within the last couple of weeks, because we had GSA and other things happening, but you sort of see these three different sort of trajectories, if you will, if you line these peaks up, that suggest these relict peneplain horizons. And so our modern level, right, the Susquehanna River is in the blue arrows in both profiles, and if you're looking at again the cross section at the bottom, this is an attempt to show where the gravels were, and this is from Stowe's paper. So again, you see the solid line representing the Susquehanna River, this what's labeled stream profile, and then sitting on top of that are these gravels, these terraces. Again, not exactly at the same exact elevation, but slight inclines and slight declines. But that's reflective of localized uplift or subsidence, within the strata, in the time since their deposition. And then I found this last weekend and was really excited about it. So I was reading an article, and it referenced this National Geographic magazine article from 1890 called "The Rivers of Northern New Jersey with Notes on the Classification of Rivers in General." And this is a William Morris Davis publication. I love these old, our students some days are told never to go back to the old literature, and I think that that's rubbish, right? You got to go back to this old literature, and even if it's not in our area, it still has beautiful information that is recorded there. And one of those things to notice here is what's called the Schooley peneplain. One of those peneplains that I drew the line for is the Schooley peneplain, right? And so you'll sort of see this, folded strata, if you will, in the cross section up there, all the fold and thrust belt of the valley and ridge. Of course, you can see in the subsurface cross section, you can see the Triassic lowlands and the submerged part of the peneplain labeled shoreline at its, right? So this represents the time when sea level was much higher, right? The Triassic formations, right? The Gettysburg lowlands were underwater, right? Or in New Jersey, the Passaic, right? Lackatong and those areas. But anyway, needless to say, you start to see these beautiful time series images come out. And so this shows you that the base level had dropped, that the shoreline had shifted, and that the river systems begin to entrench downward into what was previously, the ocean, shelf environment. And then as we continue forward, the rivers not only entrench downward, but the rivers begin to erode and widen their river valleys, and more sediment is entrained. And if you see in this image, the valley and ridge with its sort of trellis type drainage patterns begin to emerge for the first time. right? And then we kind of come to what we sort of see today. And so the Kittatinny Valley, right? If you follow that into our region, that is the Cumberland Valley, right? The Antietam in the Triassic, the Antietam Highlands there is South Mountain, the extension of the South Mountain in that direction. And of course, you see the sort of Piedmont, to our south and east. So these are to me quite telling. And so this beautiful diagram is a modernized version of that. This is out of an online textbook called the Sage Handbook of Geomorphology. And again, it's the typical ridge and valley Appalachian landscape as it was sort of developed. A horizon represents the sort of schooly type peneplain. B represents the first level of incision, and C represents the sort of modern, if you will, and so the softer rocks continue to erode downward. So I don't have time to walk through that, but again, there's the schooly, right? The incision in phase B, and then down into sort of phase C in this particular way. But again, this goes all the way back to the 1890s, and this work is basically foundational to our understanding of fluvial geomorphology. So let's fast forward to the work of a wonderful colleague, Frank Pizzaglia over at Lehigh, and some of his students and colleagues. And what they try to do, of course, is start to put a time, that was concrete based on absolute dating techniques. And so you can sort of see here the divisions using the, tills. So the Pennsylvania, New York glacial deposits from the Gardner et al. That's all right. And then, of course, using some of the, so Peltier, you saw me present some of his statements earlier. You see the sort of terrace level from Pizzaglia up there as well, QT6 going all the way down to QTG. And they went ahead and established, the ages and approximate elevations as they were. And this, of course, is for the Marietta location. Now, one more step that I did, and this was 2 years ago. Our field conference was up at Erie, and we spent some time in the field with Eric Straffen and other colleagues, and we got to see a number of these till deposits out there, and it got me thinking a lot more about connecting the Western Pennsylvania to the Eastern Pennsylvania region. And so you can quite easily, in the blue boxes here, I just colored them blue for, the ice advances. These are the times when the tills were basically laid down and then retreated. The red intervals represent the interglacial time. So during blue times, base level was dropping and would hold down low. And then during the red intervals, right, sea level was rising or holding at a higher level. And so it's pretty easy then to begin to be able to establish pretty reasonably, the age relationships, if you will, of the different terrace levels. All right. And again, so then we can start to do the same thing. We can go back to Fort Hunter where they haven't done research, and we can begin to assign, the terrace nomenclature of these prior workers. But there's still some questions, of course, and those questions are big ones. And so, this was the question that I was given when I was asked to give this talk for Fort Hunter is how old, are the bluffs that surround Fort Hunter? And I can pretty, confidently and respectfully indicate that they are, they're younger than 130,000 years. And of course, that's the majority of our built infrastructure sits on that T3 and T4, T5 interval. And I think that I feel fairly confident that we can do this over and over again everywhere that there's a terrace with these constraints. But what about caves? That was one of the things that I said at the outset, right? And what about Shippensburg? What about Chambersburg? Well, this is again a topographic profile following the yellow line from the Susquehanna River. And unfortunately, I should have ran this the other way because schematically looking at this, the left there is to the right to the north and east. And so anyway, get away from that. My cartography professor would have said you fail, but anyway, so here in Shippensburg, where's Shippensburg? So this is for my wife's benefit. She wouldn't be able to pick Shippensburg out on a map most of the time, just not picking on her, but no, she would. But anyway, what's so significant about Shippensburg and Chambersburg and cave systems? Well, okay. Again, you can trace out, if you want to, these base level and peneplain features. And in fact, we hear the term Harrisburg peneplain used, but an earlier worker had actually proposed in a U.S. Geological Survey piece, as well as in a GSA bulletin, to actually rename the Harrisburg peneplain to be the Chambersburg peneplain for lots of really good reasons, but for some reason it never caught on. So maybe we'll talk and think a little bit about that in the future, but there's some value in doing that, in part because the Chambersburg peneplain is slightly higher, and of course, as you follow that peneplain to the Susquehanna River and to the Potomac River, it's beautiful because it actually allows you to connect different parts of the river basins. Anyway, so this is going back to that 1942 publication, I think. Again, Potomac River and Williamsport, Maryland, and Susquehanna, Harrisburg. And the attempt, of course, was to place these berms, these river gravels within the stratigraphy here. And what we did this summer, right, is we began to look at cave systems. And the goal was really foundationally, can we get geophysics, GPR particularly, to image these caves? That was the simplest question, right? It was, can we see these caves? And so we had the great fortune of being able to work with Black Coffee Caverns, just southwest of Chambersburg. If you haven't had a chance to visit that cave, it was on our pre-meeting field trip, for FCOPG this fall. That was so hopefully that'll happen next year. Carnegie Cave is a long-standing cave in the Shippensburg. It's the one that's basically sitting underneath Interstate 81. It's the one you have to, crawl through a 3.5-foot culvert all the way under both lanes of Interstate 81 to access this cave. But it is the one that's still publicly accessible, and Franklin County Grotto is fantastic at helping to keep that accessible. But anyway, so there's where we are, and I don't have a lot of time to show you a lot of the work, but what I wanted to show you is the radar-grams real fast, okay? And what you have here are really pretty prominent, reflectors, anomalies in the subsurface. And when we started to look at these, we began to see several cave horizons. Now, the day that we were here, we took one instrument, our 250 megahertz antenna, and we had a depth of penetration of about 8.5 meters, maybe a little more. After we corrected this for the limestone ambient ground velocity. And what I've done here on the right is a little screenshot of Bernard Smeltzer's cave map. And black box there represents the location of the house that's still there. And you actually go down the basement in a set of stairs and into the cave system. And we were able to, where we ran our topographic profiles or our GPR profiles, we definitely intersected these cave horizons. And so they were, so proof we could do it. The students loved it. They could go underground and experience what a cave looked like. And then they could actually see the radar reflectivity of that. So then a couple of days later, we were able to go to the Shippensburg cave. That time it was in Shippensburg. So we took both instruments with us, the 100 megahertz and the 250 megahertz. Students ran the 250 megahertz back and forth. Hey, we got 3 cave horizons. Then I said, let's just do a wildcat run. Let's go for a little. So we went down the pasture, following the horse paddock, kind of winded our way around. And on the last fleeting moments, we packed up and left. And so honestly, I didn't even look at the 100 megahertz data. The students presented this at GSA in Pittsburgh, but the 2 days before we went to go, I was like, we should look at that 100 megahertz data. And what you see here on the 100 megahertz data is that we ended up with a penetration of about 20 plus meters, right? And not only did we see 3 cave levels, but we had actually identified a 4th cave level that were down below. And so, again, this is very preliminary work. And again, the approximate position of our initial set of profiles up there, that blue dotted line, conforms to where we were running, where we think we intercepted most of the cave levels. But here's the thing, Smeltzer's cave map does not extend to those lower levels. So there's much more cave system there than is known. And when we, put this together in a topographic profile for both Black Coffee and Carnegie Cave, what we find out is that the modern 4th cave level system is actually below the surface of Bird Run, the local stream. We all know that Bird Run for a long time has been a disappearing stream. It's down there in that 4th cave level, most of the time. Now, let me bring back a little schematic from Wegman and Pizzaglia, because I don't have a lot of time to chat. I'm already over time, I know. But Pizzaglia has begun, and his students and colleagues have begun to build these models for developing these cave horizons and then connecting those horizontal caves and the speleothems that occur within them. And so when you do that work, when you begin to sort of think about that, the horizontal, cave passages are, in his model, are linked to those terrace levels, right? And that these sort of terrace levels represent sort of high stands, warm intervals. And then speleogenesis is when sea levels drop and the cave formations begin to, the river entrenches. And then infiltration, drip, 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 you're building your stalactites and stalagmites. So this is a lot more work to do, but the next, of course, goal, and this will be the work that my students are going to do for the Northeast GSA meeting coming up in New Hampshire, is to really spend time looking at the correlations between the terraces and the cave levels, to see what we can come up with in terms of linking the cave systems to these fluvial landforms. And so we think, at least hypothetically right now, that the uppermost superficial cave system that right now I'm calling it the goat pen level, because that's where the goats were stored at the farm. We think that that's probably Illinoisan in age, and therefore the lowest one, the one that's below the ground surface at Bird Run, obviously is representing sort of a modern. But again, this is hypothetical work. It's a work in progress, and I'll end there because I'm out of time. So
Thank you.
yeah.
So we do have questions. Those of you online, you can put it in the chat. Put your question in the chat, but anyone here want to start off with a question for Sean?
Third question. Can you provide some more information about these glacial features that you saw on the north and south sides, what you call North Mountain?
Kittatinny Ridge.
Blue Mountain. But, you said there were some glacial features kind of on the slopes. Could you describe what those are?
Yeah, so those are really interesting. And actually, Gail was on one of those features this summer with us as part of the field conference. But these, again, tend to be, they have a fairly steep riser with a fairly flattened bench, steep riser, fairly flattened bench. And they oftentimes, the benches will have, sort of a unique morphology and they're at an angle. They're not exactly slope perpendicular. They're sort of tangential to the slope. These are you look at, I took this one particular site that I was working on South Mountain. GSA a few years ago, and Mr. Glacial from Geological Association of Canada was like, those are solifluction benches, 100%, no doubt in my mind.
There are what?
Solifluction benches, right? So this is, so during periglacial conditions, when the ground is frozen very deeply, superficial material begins to warm and begins to, become mobile, but while at depth, the permafrost is still hard. And so there's a creeping that occurs. And so these sort of surface materials produce this characteristic morphology. And so once we discovered them in a few places, and Helen Delano and others have identified them in their early work, from King's Gap and other places, they're now they just like stick right out. Once you see them and you learn how to identify them, you find them on almost every one of our slopes.
So these formed during what time period? Glacial.
So that's the question. That's $1 million question, because during each deglaciation episode, it appears the conditions would develop so that they could move. So whether we can say that these are all, late Wisconsin solifluction benches, or are they, right? It's so looking at the soil development on top of them. In some cases, it looks like they could be, some of them as old as Illinoisan, and sort of warming into the Sangamon, others Wisconsin, but yeah, they're really awesome features. And some of them actually became more fluidized and let loose. So we have another site where there's lobate features that actually extend over top of the other forms. And so fluidized flows late in the dewater and melting time as well. So yeah, those are cool.
I think it's great.
Very much so.
All right, we have a couple questions.
Okay, so it's your kid number 4, that bird run. Wouldn't radar be pretty much limited to groundwater elevation? Like you see groundwater there?
Yeah, I think we're starting to see the top of it. The one thing about this summer was we were dramatically low. And so I think that was one of the factors in being able to image it. It's still pretty low. Right now, there's actually not water flowing in Bird Run. But interestingly enough, one of my colleagues in the biology department has been doing some dye tracing. And we're actually able to see water leaving Bird Run and flowing into other springs. So through some subterranean network in the Shippensburg area as well. So there's very likely additional cave levels. So for me to be able to say that lowest one is their most recent, I can't, but and who knows how many of these cave systems actually reactivate on older caves. So that's where the speleogenesis and somebody getting in and getting some travertine and doing some high resolution work on those will matter.
Okay, question from online. Do you have any OSL or cosmometric dating of the terraces?
So Frank Pizzaglia has been doing that work, but myself, no, not yet.
Do the terraces correspond to the inferred peneplain surfaces? What is the correlation?
So the peneplains those are sort of, especially the upper ones, those are tied to the weathering rates of the different rock units primarily. So the most resistant ridges stay high, the softer rock units go. So the peneplains are sort of lining up on those. The terraces record the levels of the river, as it was incising. So yeah, they're two different records.
So has historic coal mining impacted the LiDAR observations? And I was wondering that too. How do you factor out the anthropogenic flat?
Yeah. So that's why we use these spots specifically, because once you get up into the Mississippi and Pennsylvanian strata, it becomes very, although you can with LiDAR, you can say, well, this is definitely an anthropogenic, culm, this is mining, this is a mined region, so you can sort of walk away from that. But yes, the overprinting, the what people have done to our landscape is something you have to wrestle with.
And is there any corroboration with the Chesapeake terraces?
Yeah, that's again, and there's a lot with that, and in particular, the paleosols are being worked on as well. There's a group from the Smithsonian Institution, Lowry and others, but and then Frank Pizzaglia, of course, that was a lot of his initial work, was to bring those sort of Chesapeake and Delaware Bay surfaces up into the uplands, and so they've been doing that work.
It's relied on it from, and you a positive or.
So, yeah, I mean, obviously, I'm in many cases using LiDAR that he's already embedded in, PA Geode, but POSDA is the primary source. There's a couple of other clearinghouses as well. USGS has some links to some things as well. And our students are so gifted now. They blow me out of the water with their ability to work with those data sets. But and then, like I said, CalTopo is a wonderful tool for easy, quick visualization, and then extracting elevation data from that is rougher. CalTopo, it's a great app. You can put it on your laptop. You can put it on your phone. I do everything in CalTopo now, even when I'm not quite sure where. I put a marker on my phone with that app, and I can show it to you guys later if you're interested.
The grade size differences you see on the terraces with the coarser gravels on top suggests that there might be, different flow velocities, flow volumes have an impact on what are the implications for the establishments of the terraces. It's just kind of fun to picture what the river must look like to be able to transport that size material.
Yeah, it's awesome. I had a lab in my sedimentology class where I had the students take the average grain size from Emery's project, and they had to plot it on Heelstrom's diagram to sort of see what the flow velocity would be. It's pretty dramatic, and so it's hard for me to imagine, how much water. During melting and deglaciation events, how much water came down through there to be able to move the volume of sediment that had to have been eroded out. I mean, you think about those peneplain horizons, all that negative space down to the current topographic profile had to be removed, right? Sequentially, and then carried down the Chesapeake Bay and out into the continental shelf. And so there's just the volume of the modern and the flow velocity of our modern river just could never achieve that. So those are great things. Now, to my knowledge, nobody has done a systematic study of the different terraces to see, as you go from headwaters, downstream, to see what those terrace sedimentation looked like. That'd be a great dissertation, actually, for somebody. Yes, yeah, you could do a PhD on this.
Your question? Fred Pizzaglia was here 10 years ago. He had a project. He used the nick points, basically the fall lines, for major streams. And I wondered if he acquainted you with that work and how it might relate to the evaluation of the terraces.
Yeah, and that's on my students' reading list for Christmas break. Yeah, so that's their present from me. Right? Let's talk about that, because that's huge, and especially when we start to think about these cave connections as well. Those nick points matter tremendously.
Okay, got another question come in. Is there a possibility that lower cave passage that you discovered is not connected to the known cave?
It is 100% a possibility, right? We know from some of the dye tracing studies that have been done that depending at specific flow levels, right, that water from the Bird Run watershed can actually go all the way over to Big Spring and Green Spring. And, again, there's definitely several different cave horizon levels. And from what we've learned about Boiling Spring, the distance that some of that water is traveling, is pretty remarkable. So we talk about that as being a Swiss cheese, underground, but there's no sense that each one of these Swiss cheese horizons are connected.
So another question, in your opinion, which regime has had more impact, hydrology or glaciation?
That's I'm gonna hang my hat on glaciation on that one because you need the flow volume. You need the water, you need the meltwater. And you need that oscillation between glacial and interglacial to change the base levels. I think that's, yeah.
Well, thanks again.
You're welcome. It's